रिकॉर्डिंग करतो, लाईव्ह पण रेकॉर्डिंग पण करतो, दोघे एक साथ.
Hello. Good afternoon, everyone. Let us begin the session. I would like to welcome the expert for this session, Dr. S.V. Gauri sir, Head of First Year, along with Dr. A.R. Rasne sir, Head of Mechanical Department. I welcome you, sir. Let us begin the paper presentation for this afternoon. Now, I would like to call upon the authors, Dr. Divakar Tripathi and Vaishali Rani with paper ID 3208 from Thakur Shyam Narayan Engineering College, presenting a paper, Artificial Intelligence in Software Testing for Emerging Fields. Please, ma'am.
Good afternoon, everyone. Respected panel members and all my fellow colleagues. Myself, Vaishali Rani, Assistant Professor in Thakur Engineering College, Thakur Shyam Engineering College, along with my guide, who is a co-author for this paper, Dr. Divakar Tripathi, would like to present a review paper on the topic AI and software testing for emerging fields. Starting with the introduction, as
Next.
Next. Okay, by the way. So this presentation will first see the introduction of this topic as why this AI in software engineering, software testing will be required for the emerging trends. Up till now, we have used software testing only for the normal softwares, as say as application softwares or any kind of system softwares. But nowadays, as with the booming technology, we have all the booming trends which are coming rapidly into the markets, which has taken over the world, as say as IoT, as well as we have even our blockchain technology, as well as our edge computing. These have taken over the total world. So the traditional software methods which we call as testing methods, which we call as manual testing, then we have the automation testing, the monkey testing and all this. These are not able to cope up with all these particular technologies which are booming in the industry. And right from say as 2003, it has been seen that these technologies, these particular testings, the traditional testing methods are failing. That is the reason why Google was actually hacked in 2023 recently. The reason was AI was not incorporated in testing, and that is the biggest motivation for this particular topic for choosing. Further to that, our study actually introduces what is the AI-driven framework, whichever will be incorporated into the software testing. For this emerging trends, of course, for this blockchain technology and all this, whatever we are using in the day-to-day life. In the day-to-day life, we are actually using all the data transfer, money transfer, and all these things, the cloud and all. So all the fields or all whatever are the bases whichever we are using in the day-to-day life should be actually tested very properly so that they should be secure, they should be very efficient, their efficacy should be there, and that is the reason why we are going to provide this kind of a framework. Further to that, this framework's ability to offer the intelligent test case generation will be discussed over here. How this testing will be done? Actually, the AI will be used to generate the test cases also by reducing the human time so as to create the test cases, and not only to create only the test cases but to generate the efficient test cases, we will be using AI over here. So the AI-driven solution will help all the organization, rather I'll say as a whole world, to achieve the greater reliability, the efficiency in all the future technologies whichever will be coming in the worldwide. The motivation for this topic, as I have already explained, as we have to overcome all the traditional testing methods, and so that the problems with the traditional testing methods, that no scalability is present, they don't respond to the real-time things and requirements into the emerging fields, along with the efficiency enhancement is one of the greatest motivation for this. Along with that, adapting to the complex systems, as we know what is blockchain and edge computing as well as IoT, these are very complex systems which are being built up. So for these complex systems which are being built up, even the testing should be very rigorous. That will be always done with the help of AI. Further, the objective of my this review paper is to develop predictive models for the fault detection, which takes time with the traditional methods, and the different classifications in IoT, blockchain and the edge computing. I have taken these three as my base. Further, it will be using some kind of AI algorithms, whichever are to be still identified, to auto-generate the test cases, providing the prioritization of the test cases also, so that testing should take very less time and should be done efficiently. Further, to develop the AI-driven testing mechanism to adapt the test strategies for the real-time systems. So these are the objectives of this review paper. My problem statement discusses all the emerging technologies like whatever I have discussed about IoT, edge computing and blockchain, where you require actually reducing the testing efforts and wherever the complexity of the software is more. Further, The traditional testing methods actually nowadays struggle a lot for with the parameters such as say as reliability, with the scalability in the testing, as well as the real-time adaptation into the softwares. Further to that, current testing approaches are actually very much resource inefficient, we can say, as well as they are very resource intensive. Even though we see that the automation software test softwares are available for the testing, they take even human resource, they require the human resources for running them or for execution of them. Even if we talk about the monkey testings, the automated monkey testing will again require some kind of human efforts to be given back for that. So our AI-driven solution, AI-driven testing will actually is the best solution whichever is needed to handle all these challenges which we are facing right now. AI can automate actually all the fault prediction, it optimizes the test case generation, it optimizes test certain tests, and as well as it will actually improve the test defect detection time. Further, the related work whichever has been done up till now, the literature survey includes, we have some studies whichever are done which is actually showing how this AI which will be incorporated in the software testing will be useful for enhancing the efficiency and accuracy into the software testing. So the researchers have actually identified AI in software, the quality in the AI testing as whichever is normally the top concerns with it, whichever are related to the nowadays technologies which are booming up. Further, some of the AI algorithms have been applied in real world scenarios such as COVID-19 detection, we know very well. So this is again one of the major, you can say as a live example which we have already seen, and demonstrating the versatility of the testings. This AI technologies contribute to the post-marketing monitoring of the softwares as a medical device which is called as a SAMD, ensuring all the kind of safety, efficacy and security purposes. Further to that, all the cloud-based AI frameworks whichever are required nowadays, which are moving up into the market nowadays, outperform all the human-driven testing mechanisms. So we require AI to be included so as to increase accuracy as well as the speed of testing. All these frameworks will improve the software security, the reliability, the scalability, highlighting AI's impact on the software quality. So ongoing researchers whichever are focusing upon AI's progressive role in the test task automation as well as in the system optimization. These are some of the papers. There are several papers where have been studied whichever are talking about the several aspects into the testing challenges within IoT, edge computing as well as the blockchain technology. So in 2025, recent paper whichever has been seen is the advances in AI and software testing, where the aspect whichever has been discussed is about the testing challenges. Says that IoT as well as our blockchain and edge computing actually faces real-time processing problems. So the AI is very much necessary to be incorporated for this, as well as scalability is one of the problem into IoT and heterogeneity. So that will be overcome by our AI software testing with AI. Further, in the blockchain, integrity and security for the decentralized systems is talked about into this paper. Further into the paper whichever is at the confluence of artificial intelligence and edge computing, in IoT-based applications, that is a review and a new perspective, AI techniques whichever are there for testing are actually discussed. So it says as that machine learning, deep learning, supervised learning, all these can be used for the verifications, for the validations, as well as for improving the performance enhancement and for the optimization of the testing. The next paper discusses about the level of automation. Up to what level of automation can we go for testing of these softwares with the help of AI? So, the AI-driven test case generations for IoT, it says that the automation level is always high as automated test case generation and execution is possible. Similar is applicable for blockchain as well as for edge computing with their several aspects, with the several parameters. Further, in the next paper, that is whichever I have chosen, just very few papers, as artificial intelligence for securing the IoT services. In the edge computing, which has both the technologies merged into it, actually focuses upon the security of the systems, where we have all the sensors and everything that is being applied into the IoT-based systems, where IoT says that ensuring the data integrity and privacy in the interconnected devices is the concern, where blockchain says that again the integrity and the security of the decentralized applications is the main concern. Similarly, applies for edge computing also. Moving ahead. This is a proposed methodology which we will be using, where there will be 7 processes whichever will be followed by us for this AI-driven technology into the software testing. First will be actually using the data collection with the logs from multiple systems, say as edge computing, blockchain and everything. Second will be development of the model whichever will be taking place with the help of the fault prediction as well as test case generations, deep learning methods, supervised learning methods and all that. The next process we will see will be the tool selection. The tools like say as Selenium, PyTest will be used for the automation. For the AI model training, we can use the PyTorch or TensorFlow. As well as for the tool selection for the data pre-processing, which is very much necessary, we will be using either NumPy or Pandas or any other technology also. The next process that we have is a 4th process where we have to generate the dynamic test cases, whichever will be generated automatically. So for that, exploration, evaluation and adaptation of this all will be done respectively with the help of AI tests with the new input combinations generated by AI itself. Further, evaluation will be done on the log results by the AI again itself automatically. Of course, with some supervised learning will be incorporated into it, as well as adaptation will be always done with the help of RL model that will refine the case conditions. The 5th process that we have is the evaluation matrix, whichever we will be writing, as we will be actually talking about the fault detection rate should be always very high, the test execution time which should be always very low, and the test coverage which should be maximum. Further, the next thing is framework optimization is our next stage. So over there, the learning rate, say as RL models will be used for this, the batch size, the mutation rate, all the parameters will be discussed over here. And the last one, where the final AI enhanced testing framework will be prepared, whichever will be having the use for validation of the real-time real-time objects or the real-time softwares, whichever will be incorporating IoT, blockchain, as well as our edge computing systems. So this will reduce the defect detection time. This will increase your reliability. This will increase your scalability into the testing of this all the softwares using this AI. So, as this is a review paper, we don't have the results for this, but just some analysis done on the basis of whatever has been studied as it's like automation and the predictive analytics and the security things are very much important, but the methods and the results will vary across all the 3 technologies as IoT, blockchain as well as edge computing. Further, the integrating the AI into the software testing for implementing all this is of course going to improve the efficiency, accuracy and adaptability. How it has increased, I have actually incorporated into my last slide. Further, each emerging technology faces unique challenges and AI will surely help tackling all these challenges in different ways. So comparing all these domains is done with the help of the papers and I have put up into the next slide. The further analysis actually says that nowadays the current methods actually fail to meet all the needs of the emerging technologies for all these new technologies. So the proposed AI-based framework can be effectively used with the help of the test dynamics and the heterogeneous ensuring better testing processes in the real-world applications. Next, these people will contribute to the evolution of all the software testing things by designing the AI-based frameworks that improve precision, scalability, and efficiency, which is the actually problem into the traditional methods. So AI integration will make testing smarter, more adequate, more efficient, and able to evolve all alongside new technologies. So this is the conclusion which I say that I've actually put up into the last slide where we are actually showing how the testing has been improved by incorporating AI into the software testing field. So looking to the table itself, it is very much clear that the traditional testing somewhere is lagging behind, where the AI has actually taken over the market into the software testing field. So in the case of accuracy, recall, as well as the defect detection rate, the execution time reduction, AI will be always ahead of all this. So finally, I can conclude as that AI will lower the costs, minimizing all our manual work and improving the efficacy, efficiency, as well as the security into all these growing technologies. So it will enhance again all the software reliability by detecting faults efficiently. These are some of the references which I have used for this review paper. And I leave this. Thank you. Before I wind up, I would like to thank the College of Engineering, College of Engineering, as well as Sri Krishna Ambedkar Institute of Management, Nashik, for giving me the opportunity. Thank you very much.
Okay, madam, thank you. On behalf of DVG's College of Engineering and Sri Krishna Ambedkar Institute of Management, myself, Dr. Gauri, and my colleague, Dr. Rasne, first of all, welcome you here for presenting the paper, long way came here. So, on behalf of college, we have this time to you. I have a few questions. First of all, let me know. You are doing PhD. You are research scholar?
Yes, yes.
And who is the other co-author?
He is my guide.
Okay. So he has not come today?
No, he is an ISB University at Chhattisgarh.
Okay. So you are doing PhD at Chhattisgarh?
Yeah, yes.
Okay. So another question which I would like to ask you. So here you mentioned something about optimization. What method of optimization you are going to follow here?
Sorry sir, I didn't get your question.
You mentioned about optimization. So what are the different methods of optimization?
Sir, sorry. This is just the review paper, so I haven't gone into very much details about the optimization things. I've just studied them on the surface.
Okay.
So it is just about the test optimization, but I haven't
Which
seen
is
the
your
test.
year of this research? First year, second year?
This is first year, sir. I've just completed the coursework.
Coursework.
Yes.
Please check the UGC guidelines regarding the research center as well as your guide location and your working. Another question I have. How has AI-driven test automation improved software testing efficiency compared with the traditional methods?
How is that improved? How has it improved? Yeah, there are various fields where nowadays AI.
You have to compare it with the traditional methods. You have to compare it with traditional methods.
Yes, I am comparing it with the traditional methods. As how it has improved is nowadays we require for the traditional methods, we require the test case generation. Generation that's too manually. Okay. If at all we will use AI technologies, our test cases will be generated automatically. Looking to the results where we can actually incorporate deep learning, we can incorporate some supervised learning, so as to actually use the data from them, from those technologies, and then generate the test cases. So one of the will be generation of the text spaces. The another thing will be pattern matching. Some of the times, many of the human eyes also, sometimes the human eyes also fail to detect many of the parameters for matching the patterns into the medical sciences as well as into the scientific fields also. So our AI will be useful over there with the help of all this deep learning and all this supervised learning and all these techniques, as well as machine learning also.
Okay, one more question. Can you tell me the latest AI application in software testing and the latest paper which you have studied?
The latest paper was 2025, which
Can you explain that paper? What is exactly in that?
this latest paper.
Please tell me the findings of that paper.
Findings were again that the IoT, I have taken basis, the IoT, edge computing as well as blockchain technologies actually require the scalability, reliability, security things to be incorporated into the testing. They require the results as for improving all this. So AI will be helpful. Now how it will be helpful, which models have to be used, how the frameworks have to be prepared at the further step.
Okay. Thank you. I hand over my mic to my colleague, Mr. Rasmus.
Hello. You said something about real-time adaptation.
Yes, sir.
So can you throw some light on this real-time adaptation?
The real-time adaptations whichever we have nowadays, I can just take the example of AI as you can say as day-to-day life we are using money transfer, bank transfers, whichever are the real-time adaptations. Then we have some kind of reservation systems. We have some flight control systems which are the real-time things whichever we are using. So all these actually require the scalability as well as the reliability and the security things which are most important parameters. So as well as even into the medical sciences.
With regard to the software testing, there was one point on real-time performance testing. So whatever AI frameworks are currently available, so I don't think that there are any framework which works on the real-time data input.
Sir, very few. I didn't find. I was not able to find.
It is very difficult to train the model with the real-time data. So how this issue can be addressed? Because that would be, I suppose, the major challenge in the real-time adaptation.
Yes, sir. Yes, sir. That needs to be studied, sir. This is just the first review thing that I have done. I'm so sorry.
And whatever the framework would be developed, will that be a standard solution or will that be a customized solution? Or is it software?
The framework that will be developed by Atlas will be for the customized one, of course.
It has to be customized.
Yes, sir. It has to be customized. But of course, if at all I get enough time, I would like to prepare something that will be generalized for us.
And one more question, do you think that this AI-based software testing will be completely autonomous or will require interference of the human beings?
Of course, this requires at least 25% of the human interference that's I have studied into all these 15 papers. But sir, as compared to say as 100% interference from the human beings, 25% is too much less. So reducing the time of testing drastically by human beings and increasing by the AI-based softwares tremendously.
And there was something on dynamic strategies. So can you throw some light on, or have you read something about the dynamic strategies?
No, sir. No, sir. No, sir. Not yet. Not yet.
Okay, that's it from us.
Thank you, sir.
Audience, anybody want to ask a question? Audience, please.
Hello. Ma'am, can I give the one input to you?
Yes, sure.
Dr. Gauri sir asked you, what are the optimization techniques used? Can I give the answer on this?
No, sir, as I said that this is...
Can I give
You want
From my
Yes,
side.
sir, I would love to hear that.
Yes,
Yes,
it is two optimization techniques. First is our ECP, equivalent class partition. Second is our BVA, one value analysis. These are the two basic optimization techniques of our test cases. First of all,
Thank you, sir.
this is the input. Okay. My first question is what? How to test QR code by using AI?
Sir, to be very frank, I'm still telling you that this is my review paper and this topic is not yet finalized with by the university also. I'm going for this topic. I've not done my RAC also for this. I've just started with the studies of this. So I'm really sorry I won't be able to answer.
Ma'am, what is monkey testing?
Yeah, monkey testing is monkeys are the softwares which are the automated softwares, automated and the semi-automated softwares, where you have to just submit your software under test and it will execute your software according to whatever the data has been.
No. I'm talking about what is the process of monkey testing. I'm not talking about the tools used for the monkey testing.
Process of monkey
What is
testing.
monkey testing? And
That's what is the
how you
automated or
are
semi-automated testing.
how you are going to automate the test cases for the monkey testing?
Of course, a human being has to build it.
Actually, madam, for monkey testing, test cases is not written. It is dynamic
Testing, yeah.
testing.
Yes.
And my last question: how to write the test cases for the high priority, high severity work?
How to write the test
This
cases?
is for the high priority and high severity.
Again, for that, AI will be used for, the model will be prepared, AI framework will be prepared so as to generate the test cases. So how to write, if you will say, if you are asking me about the parameters for the high level, for the high prioritization, so we have to first identify which are the major features of the software which are needed to be tested, and we have to test it with respect to the objectives, the inputs, and the say as the expected output and the actual output and so on.
Okay, thank you.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. This is all related to the black, you can say as white box testing. Not only, I can't even summarize as only black box or only white box, it will be the combination of all this. Of course, combination of all. Yes, sir? Both, sir, both. When, sir, you have to actually reduce the human work, you have to use both the techniques altogether combinedly and then prepare a framework so that your test testing will be reliable and efficacy will be increased. I haven't put it up till now. I haven't gone into depth up till now for this, sir. As I see, in fact, my RSC has not been done as yet. I have just put up this review paper. Yeah, the traditional methods, the first objective, the problem, this is the problem statement. The emerging technologies like IoT, blockchain, and all this stuff will increase the software testing complexity. Of course, these whatever are the booming technologies are very much complex in their natures. Okay, increasing as for if the software is simple, its testing will be simple. If the software is complex, its testing also needs to be very much complex. But the further thing comes as that we are going to incorporate and prepare some kind of AI model so that this complexity will be reduced. As yet not decided. But one thing that is very clear that if the software is complex, your number of test cases will be too many. So as to have the security issues to be incorporated into it, reliability issues to be incorporated into it,
and all these issues will require many of the SPCCs. Thank you.
And one more suggestion to you, colleague. Request you to please study more research papers.
Yes, sir.
The slides which you are just showing, if you go through the various PhD presentations and other papers, here you are writing introduction, then there is problem statement, exactly what is the meaning of problem statement, and the points what you have written over here. I think you need to concentrate on each point. What sir has asked, that was, he was highlighting actually the problem statement, but what you are showing that is not correct. So I request you to please study more research paper.
Yes, sir.
What should be how the researcher should give the presentation. Of course, it is take a positive, so that it should help you for
Yes,
your
sir.
final
Yes,
presentation.
sir.
Okay. Thank you from all.
Thank you, sir. Thank you very much.
Next paper, please.
Thank you so much, ma'am, for your thought-provoking presentation. Please note that the presentation schedule allows for a 3-minute introduction followed by a 7-minute presentation totaling 10 minutes. Now, I would like to call upon Mrunali Kapadnis and Tejaswini Shinde with paper ID 3226 from Sandeep Institute of Technology and Research Center presenting a paper, Automatic Toll Collection System using GPS. Please.
Hello. Good afternoon, everyone. Myself, Mrunali Kapadnis. I am degree student from Sandeep Institute of Technology and Research Center. So the paper ID is 32. Our research topic is automated toll collection system using GPS. So basically the idea is to avoid tag verifications, tag installation process. We further move to automated toll collection, which is based on the integrated vehicle GPS module. Our problem statement is vehicle ownership. So what if the person who is driving is not owner of the vehicle and he is driving, and what if the toll deduction is occurred on the owner? So that is the problem, and our system basically what it does, it deducts the toll on the integrated vehicle GPS module, and it automated contacts to the user. So the objective of the paper is to automate tolling using GPS and geofencing, reduce the RFID based infrastructure as I already told, and enhance the real-time accuracy, so that the user will be access all this information in just a minute with handheld mobile sets. Our problem statements is to the increasing vehicle ownerships, and people are not aware of those RFID cards. We visit stakeholder at Pimpalgaon Baswan. They told that people are not aware about the RFID tags. They are saying they are carrying 2 RFID tags, and the detector detects both the RFID tags, and the toll is deducted from both the cards. So they put grievances and all these stuffs happened, and fraud system is also installed, happened, they told us. So to recover that and automate the highway transportation, we propose this system, and it's also our last year project. To move just first review the literature survey. So there are some people who research about this system, which I have mentioned. So the systems are provided about image processing, RFID, also GPS and geofencing. But the problem is that to install this system in the countries like India, where people are not aware as much as they, it is very important to do that. So our Honorable Minister Nitin Gadkari has already told that the systems will be installed in India very soon, in 2019. So these are the surveys, and based on the criteria like GPS-based tooling, geofencing, and fraud preventions, we featured these papers as they are doing it or not. And last one is this work. Means our work is GPS-based tooling is done. Geofencing we are not doing yet because this is our primary kind of work. And fraud prevention will automatically done because as I already told, the SMS will be issued on the user's mobile handset. So these are the overview of the literature survey, which is giving GPS tooling criteria and all the stuffs, cost-effective solutions. Also, the system becomes very cost-effective as the module is already integrated in the vehicle. We don't have to put those cards and recharge it. We just need to recharge the SIM which is installed in that GPS module. Hybrid technologies like RFID plus GPS integration explored for vehicle identification. So RFID we are not considering for our thing. These are just the integration techniques which are being used. So this is basically our vehicle module, which looks like there is a ESP32 module, A6 buzzer, and the GPS module, which is connected with ESP32 is connected with the buzzer. When you got the SMS from the tolling department that your toll has been deducted, the buzzer will be rang and user will be notified that your toll has been deducted. This is also a notifying system. Results and analysis. This is our basic review, and we just want to tell you that this system is very automative, less time consuming, and more effective as of RFID tags. So we are trying to improve this system as much as we can. These are kind of percentage we are analyzing with respect to the matrices. Detection accuracy, toll processing, fraud prevention, success rate, notifications, and challenges. Challenges are very like network issue and SMS issue, which are occurring due to the mobile handset range. So we concluded this topic.
Hello. Okay, thank you. Your name is Kaparnis.
Yes.
And your name? Yes. Not able to hear. Loudly. Okay. You are from Sandeep Foundation. Good. You are studying final year or third year? Final year. This is your project. What can you tell me? Yesterday, when a circular came regarding the security registration from the government of Maharashtra. Do you have an idea about that? HSRP. Yesterday, regarding the transport synchronization.
I was in Pune doing my TCSM.
Pardon?
I was in Pune doing my TCSM 2 days, so I am not aware of that.
You are not aware.
Yes.
What problems Indian or the government of the Maharashtra toll facing. Do you know, can you highlight certain problems now
About what?
about the reduction of the tax at the toll?
Yes, सर जब हमने टोल कलेक्शन के सिस्टम पे जाके जब विजिट किया, so उन्होंने हमें यही बताया कि people are not aware of those tax. Like some people are doing there are specifications means based on the vehicle size the toll is deducted, right? So if you are carrying a car, so the toll of the car is different and toll of the truck is different. So some people are applying this RFID tags of car to the truck so that toll rate will be deducted according to the car. So the system is not aware about whether it is car or truck. The toll is deducted on the basis of RFID registration, right? So people are not aware of that. People are doing very fraud kind of things according to it. We are not aware of those things. So yeah, they told us these things.
On the Samruddhi highway?
No, Pimple House.
No.
We don't visit Samruddhi.
So, a lot of study is required for you now. You have to get to the knowledge. And the presentation and everything. But again, one slide only, we have not shown the name. Okay? Well done. Now, if you have student, you are trying, it's good. Okay, I hand over my to my colleague.
Whatever results you have shown, those are from your study or those are from literature?
No sir, it's from us.
So what was the size of the sample size for this study? How many vehicles you tested?
The module we have established is almost 17 centimeter, but the module
Sample size, how many vehicles you tested to arrive at this result?
we don't implemented it on vehicle. We just yes.
For prototype also, how many? What was the sample size? How many samples you tested?
Yeah, we put that module in a toy car and we just get the latitude and longitude according to 50 meters range. We got the latitude and longitude and if the vehicle is tracked, if the module is tracked over the system software, then the system will deduct the toll.
So how many toys you tested? That's what I'm saying.
There are 3 to 4 toys on the prototype. According to the range of this, some are catches on the 50, some catches, if the range is strong, they are 10 meter also, catching 10 meter also.
Do you think that whatever results you are showing, that toll processing time is less than 3 seconds for a toy car and for actual car? Will it be same or will it be different?
We doing it on toy car, so our toll is means the message got in less than 3 seconds.
So, but what do you think logically, whether it will be same or it will increase?
Manual differences.
So around 5 seconds. What about the vehicles which do not have the GPS system? You are proposing a system for a GPS system,
Yeah.
but there are many vehicles which do not have the GPS system.
There are some modules available in the market. Also, Jio has launched their module. You can install it in your car and you are ready.
So what is the cost basis as compared to RFID?
It's cost around, that Jio module is cost around 1200 or 1800.
So RFID is much more cheaper than that.
But it is the one-time investment. If you install it, you cannot install it again and again.
RFID is also one-time investment.
You need to recharge it. In this system, you just need to recharge your SIM, 2G, 3G SIM.
Both things are same. If you recharge it, the money will be deducted.
Yes.
Only thing is you
But
have
the
to recharge
things
it.
become more convenient because it will become automated. In other countries, it's already implemented.
No manpower will be required. That's what they are. So for maintaining the system also, nobody will be required.
We just required one operating station. That's it.
So no system will be there on the toll booth.
Yes, yes. It become more transportation system become more fast.
So how does it will be detected when the vehicle passes the toll point?
There is area, latitude and longitude. When the vehicle enters, the system continuously tracking the system, the latitudes and longitude. When it got it, they catch it and provide the.
You have used the GPS phone. Okay, you know the frequency of operation. The frequency of that particular GPS phone. It is a 2G or 3G or it is both.
We 2G and we can implement the same 2G or 3G, not 4G.
You have used the 2G or 3G. The
We use
frequency range
2G.
for that.
2G.
The frequency range. What was your downlink and uplink frequency for that?
Sorry, I don't.
Then how you can say that it is a 2G? If you don't know the frequency band, then how you can say that it is a 2G?
I am talking about the SIM which I installed.
You just show your the block diagram.
Yes.
Just show the block diagram. It is the wireless communication or wired communication. Which one is the transmitter? Which one is the receiver?
Transmitter.
As per your diagram.
Transmitter is the that E6 GSM GPRS,
Okay.
and receiver is the ESP30,
And what you
which is integrated with the software.
okay, but what you observe with this block diagram or the diagram implementation diagram, it is the wired communication, not the wireless.
It is the vehicle module
Okay.
which is installed in the system, which is integrated with software.
Okay.
So when the
What type of hardware you expected at receiver end?
what type of sorry?
What type of hardware you require at the receiver end? It is your transmitter which is located at the vehicle.
Yes.
Okay. At the infotainment center, what type of hardware you expect?
Software. There will be the software.
Only software is sufficient for that.
Desktop all the power system will be there, and
How the signal is get transmitted from your transmitter to the receiver. This is your transmitter module.
Yes.
It required to transmit some sort of
some
signal.
signals.
Okay, what kind of signal you transmitted from this? Okay, have you used the analog to digital converter?
Yeah.
Okay. What will be the, you can say that the size of that particular ADC? Bit resolutions of your ADC? It is 8-bit or it is a 3-bit, it is a 4-bit, 7-bit, 6-bit. Based on the bit resolutions, you can decode your data.
Yeah.
What will be the, what was your size?
Sorry, sir.
Then how we assume that you implemented this? If you don't know the ADCs and all these things. And sir is asking with the sampling rate related to that. What type of ADC is there? There are different types of ADCs are there. Which processor you use for this one?
Yes, we got
It is a how many bit processor? It is a 16-bit, 32-bit processor.
32-bit
It is a processor of the controller.
processor.
Processor. Maximum memory available with your processor is that is the answer. Indirect. Maximum memory available with your processor. It's require adding lots of. First of all, study the processor. Processor selection is the, I think, the heart of any hardware related with the embedded system.
Yes.
If it is 8-bit or 16-bit, why 8-bit, why 16-bit? What will be the maximum memory? What will be your system memory? What will be your program memory? Based on that, you have to decide your program size. You have to execute with that. just take the ready-made module, interface with that one, integrate. Your idea is good. As per the transport ministry, maybe within 2 to 3 years, this GPS system is available with all the vehicles.
Yes.
There is no need of your toll system, automatic toll collection systems now. Based on your that particular moving toward that particular route, automatically tolls get integrated with your bank accounts and all. Again, in your literature survey, just show me the last line of that. Literature survey last line. Where your actual work it is in, I think, highlighted. Last line. This work, it is a GPS based tolling and the fraud prevention is there. And geofencing is you are skipped for that. And I think in your result, your comment, some comment is given on the geofencing. I think first comment with your result. It is related with the geofencing. And in your literature survey, you say that you have already skipped the geofencing.
We don't skip the geofencing, we don't study the geofencing yet.
Without studying the geofencing, how you can give the result, better result for that? For first result, it is I think 87% no, for the geofencing. Just click on it.
Yeah.
It's the first result.
Yes.
Result related with the geofencing.
Yes.
And right now you say that you have not studied the geofencing. How it is possible?
Studied means, sir, we have literate according to the literature survey. We don't do that.
Yes, my simple question is related to that one. If you are not aware with the geofencing, how you comment with your result that with your implementation, geofencing gives the higher accuracy. Okay. So please study the basic things which is required for implementing any problem statement. Okay. Understand the software as well as the hardware requirement, and then go for the implementations. Okay. It's a single, we can say that the transmitter part related to that. For the communication, a lot of things are required. Okay. So please be studying that basic things. You use the mobile.
Yes.
Which mobile you use for that one? Is it 2G, 3G or 4G?
For the
For receiving the SMS.
my coach.
Means your mobile is supported the 2G band, 3G bands and 4G.
Yes.
But you don't know the uplink frequency for that. GSM 900 you use maybe,
Yes.
or GSM 1800 you use.
9.
900.
Yes.
With GSM 900 you use the automatically the answer for that.
Yes. Thank you very much.
Thank you so much. Now, I would like to call upon Professor Deepak Avinash Kulkarni with paper ID 3198 from ISB University presenting research paper on proactive transformer health monitoring using IoT and machine learning for early fault detection and classification. Please sir.
Good afternoon, everyone. Thank you, Vidyarthi girls, College of Engineering, and Sri Krishna Dharmakar Institute of Management Studies for giving me this opportunity to present the paper in their first international conference. Myself, Deepak Kulkarni, along with my co-guide, Dr. Swami Swami of ISB University. He is the Dean of ISB University and my guide also. I am here to present my report on proactive transformer health monitoring using IoT and machine learning. This part I am going to submit as my part of my PhD thesis. I am doing my PhD from ISB in Chhattisgarh. So we will present about what is basically the transformer health monitoring. So this is what we are talking today. Today, if we see all the devices that we are using are mainly based on power consumption. Day by day, the power consumption is becoming one of the most crucial component. And if we come to the manufacturing industry or any process industry, the power failure is the most sensitive event. Because if the power fails for a fraction of a second also, it can cause some specific monetary loss to the industry. So we are proposing a model where we will determine the possible power failure before the fault has occurred. So we are proposing a fault detection model before the real-time power failure occurs, and accordingly that kind of monitoring will be done and information will be given so that the power failures can be prevented in many cases. So today the modern power system is implemented for accuracy, reliability, real-time fault detection, fast response time. These are the major factors on which we are going to respond. What is the basic drawback of our existing system is they are having a problems of overloading, malfunctioning and faults. Overloading is a basic mechanism that we are facing today everywhere. That is the reason the failure of the power is the main factor, is the overloading. So in this model we are proposing to determine various parameters like temperature, current, oil levels and moisture levels so that the transformer can be maintained accordingly. So we need to continuously check the real-time data and can predict the fault by analyzing the data. This is definitely going to enhance the economy and reducing the maintenance cost, because if the power failure takes place, the industry will be shut down till the power gets recovered. Even if they have a standby power source like we have got high efficiency generators, but still for a fraction of minutes the system may be, or fraction of seconds the system may have a power failure which can cause to a company. So we are implementing an IoT based system so that we can prevent the damage due to transformer faults and can build up a flexible network for real-time observation for fault prediction. Basically our basic concept would be fault prediction. We are not talking anything about the fault monitoring or we are not talking anything about the fault repairing. If we could go for fault prediction, definitely before the fault occurs, we can overcome that fault so that whatever the losses is taking place in the working efficiency can be reduced. Also, this is going to be a fully automatic network which will be eliminating the human interferences and errors, because whenever there is a human interferences, there is always a delay, there is always a error calculation part. So for this we are using the real-time systems which is based on IoT, and we can also implement this for remote monitoring which will reduce the risk and detect time to detect changes in the parameters. If it is a local transformer, it is very easy to determine the fault or to repair the fault in this whatever the time. If the transformer is laid on a remote place, then it would definitely have large amount of time for the changes in the transformer parameters. So what was the basic motivation given for this study is how the transformer health is to be tracked. The main problem is power failure. Again, I am stressing on the point of power failure, which is mainly because of transformer failure. So we are focusing on transformer health. So if we could determine what is the health of transformer related to the oil level, temperature level, current levels, so maximum times we can prevent the faults which can occur in the transformer. So we will have a system which will give the real-time monitoring of the faults and will categorize them. Categorize them means whether it is a direct failure or whether it is a mechanical failure. So accordingly we can take some steps before the fault has actually occurred. So by anticipating the possible problems and proactive maintenance will reduce the expensive disruption and transformer lifespan. So we will also, this study is also going to help for power industry optimization asset management, which will be helping for a more reliable and efficient power distribution. So the objective is to design a system for monitoring different parameters of transformer. To analyze and predict, we are using some machine learning algorithms. We will classify whether it is a direct failure or mechanical failure. We will generate an SMS for the fault which has been detected and fault prediction is being done. And then we are analyzing the system efficiency by using various data sets. So the basic problem statement again remains the same. Regular monitoring of the parameters is required so that overloading, malfunctioning and the faults which can occur in the transformer can be definitely prevented, which can occur because of the temperature increase, current levels or oil level. Sometimes the oil level drastically drops down and then the transformer heating takes place. As the temperature goes beyond a certain limit, automatically the transformer is going to fail because of excessive heating. So for preventing the temperature failure, we are using the oil cooling systems. So the oil level goes down, automatically this will relate to the failure of the transformer. So the main is to determine what is the oil level. So So we will talk about a real-time monitoring system which will check all about these parameters and will predict the fault before it does occur. So we will talk about the threshold parameter, and if the values of the parameters are touching the threshold or just below threshold, alert system would be given. Some related already work has been done with respect to this particular systems. But what has happened, all this literature that we have gone through in the previous part, they were doing all the monitoring or determining after the failing has occurred. None of these systems have gone for a real-time monitoring or before monitoring. Let us say this is a pre-monitoring or pre-fault detection. So they have done the monitoring after the fault has taken place. So there was a downtime, which is definitely possible in industry. Some of the models were inadequate to analyze data. They could measure the voltage level, fluid level. They can connect to the cell phones to give an SMS alerts. Okay, they can increase some of the parameters were increasing the energy efficiency. But the major observation was they were not talking about proactive or pre-monitoring or predeterminations of the fault. Definitely sensors would be required for all these kinds of parameters. So some of the models have gone for sensor monitoring also. Inadequate precision was also determined in the previous models. Some of them were too much expensive. Some of the models were used only for dielectric health, but today we also talk about the mechanical failure in the transformers, and some of the models were only made for a limited set, which cannot go for entire. So this is the model that we are proposing, or which we have already set up. So as the center, you can see there is a transformer which is supplying a load to the load continuously. And to that transformer, various kinds of sensors are being connected. Some of the sensors like level sensor for oil, then temperature sensor for transformer, short circuit sensor, current sensors. So different types of sensors are being involved. As per the transformer weightage, wattage, and the ability of the transformer to supply the power, the efficiency or the take-up time of the sensors can be changed. So in the proposed model, we are using this kind of 4 sensors. They will be real-time monitoring the transformer, and they will be giving this information to the Raspberry Pi. From the Raspberry Pi, this information to the internet and will be given to the monitoring station, where it will be continuously monitored. And if the threshold parameter is touched, automatic sensation will be done, and fault detection. Okay, again I am repeating, pre-fault detection before the fault has occurred. So I will say there is a pre-fault SMS will be given to the monitoring station, so the team can immediately reach to that site and they can cover up the fault which may be occurring in the system. So this is what is the basic proposed model, and for that particular process, so for doing the efficiency testing, we have used a PyCaret model. This PyCaret is a data set process. They are giving the data sets for testing of our models. So we have efficiently used this data set for developing and assessing the model to ensure the accurate performance and evolution. Also, we have ensured that the messages and notifications are sent to the application to the devices before the time or on time, so that the real-time fault detections can be done. Various algorithms were used, and on every algorithm the data set was being tested. So these are some of the parameters on which the testing was being done. So various models were taken: extreme weight boosting, extra classifier, variable boosting, random forest classifier. Various models were done. On many of the models we have gone for a data set testing, and we have come to the parameter of accuracy, area under cover, recall, precision. All these parameters were tested, and the most significant that we observed for fault detection was an extreme gradient boosting, which has provided an accuracy of 0.99%. 0.99 means 99% accuracy was given. Area under the curve is also 0.99. If this value is 1, if area under the curve value is 1, that means it is the extreme precise parameter that is taken out. This is the standard that has been given. So this kind of a model is given 0.99 area under the curve. So various models were tested for various parameters. So we have taken this kind of an extreme gradient boosting, which has given an accuracy of 99.16%, AUC of 0.99, and if you see the trailing duration, that means how much time it requires to give the system, imagine fault detection is 0.6170 seconds, And as far as the extreme reading which was taken only 0.42 seconds. That means in a real-time monitoring, you can say that if I talk about 0.42 seconds, means it is practically a real time only. 0.12 seconds is nothing. Even if I start counting 1 second, before I start counting that 1 second has already passed. So 0.42 seconds is nothing, so we can relate this to the real-time monitoring of the transformer which has been getting under failure. So this is what we kind of notifications that we'll be getting, as you can see on the right hand side of the slide. On the user's desktop or on the mobile, he would be getting the SMS and also indicating what kind of fault is occurring. Like LOF, if the fault as LOF is coming, that means it is the low oil fault. So it is not only detecting the fault, okay, it's also classifying what kind of fault is occurring. Like at specific time and specific day, if it is talking about the LOF, that means he has detected the low oil fault. Same way, at different times you can see we have talked about LVF, that is the low voltage failure. We talked about the OCF, that is the overcurrent. So all these parameters are tested continuously, and whichever parameter value goes below the threshold, that value or that indication is directly given to the substation monitoring elements mobile. So he can definitely go for maintenance or monitoring of those things. These are the different types of references that was going to refer. Some of the references, many references are still there, some of the references are being considered. Yes, thank you, sir.
Thank you very much. Now, I'll directly hand over the mic to the audience because the topic is. Okay, over to sir.
What kind of the reliability model? How do you place the reliability of your model?
Sir, by using the extreme, we have developed a hardware model and we have run the 5 tera data set on it and used the extreme gradient boosting model and we have got an accuracy of that.
What is the accuracy predicted and what confidence level you predicted?
Sorry?
What is the accuracy you predicted? What confidence level you predicted this accuracy?
So it's a real time, sir.
And what confidence level you produced? Whether it is 95% confidence level, 97 or 99?
97 to 99%.
What was the source of the data points that you used for training models?
Sir, PyCaret is a it's a Python-based data set available. It is freeware available data set, which is developed only for developing and testing of models. So we have taken that data set and tested it.
There was no data on real time?
Sir, for real time testing of data, we would need the permissions of the electricity board to install this model, and then only I can go for real time testing.
So real time testing has not been done.
Real time means once this is getting approved, then we will go for patent filing and then we will install this on our electricity board. That kind of parallel work is also going on, sir.
And this study applies to all types of transformers?
Yes, sir, yes. No, this is for all types of transformers, for residential purpose also and for industrial purpose.
So whatever factors we have studied, those are common for all transformers?
Currently the parameters are for both, for industry and residential. But whenever we will enhance this project for industry, definitely some more parameters have to be also taken, and the downtime has to be also precisely brought down, because over there microseconds and nanoseconds will be also considered over there. So that high level sensors have to be used in those cases.
Sir, in your database, oil levels related data is available.
Sorry, sir.
Oil levels data is available with your database, PyCaret.
Sir, in PyCaret database, they will always provide some oil values which will be directly. Yes, oil levels also. That is the reason it has given LOF. In the notification is also given the low oil levels.
Okay, means that data set it is with some standard database.
Yes.
It is been implemented with the hardware related
Yes,
to that.
yes.
Okay. And in your that particular the block diagram again, only two sensors are interfaces.
So,
Temperature
sensor. So it is kept in the vicinity. We are not directly, temperature sensor is not connected to transformer. It is kept near the transformer.
Yes. Only two sensors are there.
So level sensor is a oil level sensor. Then we have got a current sensor, then temperature sensor. And in case if there is some short circuit taking place, which will definitely give some kind of fire or smoke, that can be also sensed to ourselves.
Have you tasted this particular system?
Yes, sir. It is interesting.
And second thing, I observed that you have used the IoTs and all these things.
Yes.
But with these implementations, I am not be confident of that one. IoT is available with these ones.
Yes, sir. It is working, sir, because we have already got the testing. The screenshot that has been placed is actually what I have installed on my mobile also.
Okay. If I will talk with that particular the IoT related to that one, then the data rate is the important parameter.
Yes.
Okay. What will be your data rate for the communications with your system, the network system?
Sir, it would be definitely depending upon the location of the transformer.
No, but IoT is introduced with the high data rate.
Yes.
It's the basic things.
Yes.
Before to that, or before to the 4G communication, we are not talking with the IoT related to that. From 4G and 4G advanced, we talk with the IoT related to that. So for your systems, have you seen something related to the data, that particular data rate related information? It is so 10 Mbps, 20 Mbps, 30 Mbps.
So it's going in, sir, Mbps. It's going in, definitely going in, sir, Mbps. But I cannot give the exact value of that payload really. But
so again, if I consider the Mbps related to that, the continuous bit stream is required for the transmissions related to that. That type of, we can say that again the sensor is required. Our conventional sensor is not.
yes, sir. Sir, this is a proposed model or a prototype model. So that was I was saying. Once we want to implement this on a real-time transformer, then looking at the parameters of the transformer, its loading capacity, its supply capacity, according to that, matching sensors have to be installed.
So again, you have to work with that particular voltage divider network.
Yes, definitely, sir. Definitely, sir. Because
most of the times it is the three-phase related to that.
Yes, sir.
Again, you have to work with the frequency related parameters. So since these are the DC components, these are verified models and all these things are the DC components, where your frequency is Z.
Yes.
And these are related with your AC component, where the frequency has 50 Hz.
Yes.
Then how you can solve that particular problem? AC to DC communications related.
The Raspberry Pi, sir, which is having installed inside it, will take care of all this, sir. Because it is a system on chip devices that we are using today. So just we have to interface the sensors and then it is going to do its own work.
So it is a system on chip, but for AC to DC conversions,
so it is built in ADC.
For conversion of the analog to the digital, the AC devices are the different one and the DC one the different. Your Raspberry Pi, these level sensors, your 16x2 LCD and the sensor, these are the DC.
Yes.
Okay, and your transformer, if I consider it is an AC related side, then how you can communicate with that? Generally, we have used some sort of the device where we are converting from the AC to DC.
So it is built in A to D converter, without which cannot be done, sir.
A to D is related with the just for the analog to digital converter is the data, not with the voltage related parameters. So the current.
So voltage, whatever voltage level is detected in terms of volt, that will be taken into the digital parameter.
Again, the more we can say that the easiest solution is or easiest way related. Ask the same question. Have you used any type of rectifier with your implementations?
So definitely it has to be used.
Where is the exact locations with these?
So rectifier will be used to supply all that to the particular all the DC components which are used in the system.
But it is not even related with the transformers and all this.
No, sir. It is used as only power supply to the DC components.
And how we can take these sensors, the reading from the temperature sensors, short circuits and the level sensors?
Sir, they are powered by DC sources only, and they are kept near to the transformer so that we monitor the values and it will give it to the Raspberry Pi only.
Any questions from audience?
For power transformer, can you tell certain key challenges for implementing IoT-based predeterminants?
So over temperature, power consumption, then overheating of the transformer and over currents. And sometimes in high power consumption areas, low currents are the main. Because of excessive power drain out, the current levels will fall down. That is the main challenge. And because of that overheating of transformer will take place, which will lead to the mechanical failure, dielectric failure concept.
Thank you.
Okay, thank you, sir.
Next paper.